So, remember I had that duck walking around on my iPad? Why is there a duck on my Notability? Notability is the app I was using. The duck, named Inky, is Notability's animated mascot, appearing to celebrate April Fool's Day / spring by waddling across your notes. This interactive feature, known as Inky Mode, allows you to drag her around and watch her interact with your content until April 7th. So I figured out how to turn it, well, it tells you right here how to turn it off. But when I'm writing, it gets in the way and I can't write where it is. Why would they do that?
For April Fools.
Yeah,
They're just trying to prank you and make
Their
you know.
excuse.
they got me. All right, any questions on anything we're working on here? We're gonna move on to 10.5 today. I don't wanna do that last problem, actually. That'd take too much time. If you're having trouble with that last problem,
We'll do it in the math.
is anybody gonna ask about the last problem? Okay. I was on duty in the math center yesterday. I'm not on duty today or tomorrow. Have an office hour, but that already happened. Anyway, let me know if you're having trouble with that.
It's due tomorrow at midnight.
Yep, tomorrow at midnight. Do you know that today's halfway through this week? We only got 7 weeks left, including this week, and now this week's almost half done. Isn't that crazy? It'll go quick.
Yeah.
All right, questions on anything else here? You also have 10.4 open. Oh, 10.4 is what we're talking about. I'm sorry, that's all that's open. Good morning. All right, well, before we go on to today's topic, here. So these are the things we've been studying. Good morning. The internet, at least when I came in here, it was down, and this is operating off my mobile hotspot right now. So my phone will probably go dead. But anyway, let's just review some of this. Divergence test. I'm not going to go in the order here. When approaching one of these problems, the divergence test is the first thing you should consider. All right? Always check the divergence test. If you look at that expression and it obviously, the limit of that a sub k expression there, if it obviously does not equal 0, it equals something other than 0, diverges. If it equals 0, it's inconclusive. But if it's something other than 0, boom, diverges, finished. That make sense? So sometimes we can spend a lot of time and effort trying to use one of these other tests, and they might work, but sometimes we'll do that when it would have been just really easy to use a divergence test. Okay? Now, if the directions specifically say use this or that test, then do it the way the directions say so that you can get practice using that test. Does that make sense? And on an exam, I might want to see you carry something out with a specific test. So you need to get practice after. But anyway, that's divergence test. That's a limit of the expression in there is not 0, then it diverges. If it is 0, then it's inconclusive. Cannot be used to prove convergence. Geometric series, that's the one where to generate each term, we multiply by something, multiply by 1/2, multiply by 3, whatever. That's a geometric. If the common ratio that we multiply by is less than 1, the absolute value of it's less than 1, then it converges. If it's greater than or equal to 1, then it diverges. Integral test. Is there a fly flying around here? You see the shadow coming across? Okay, integral test. If the integral converges, then the series converges. If the integral diverges, then the series diverges. So when you hear that, it seems like a no-brainer. Let's just use the integral test. If it converges, then so does the series. If it diverges, so does the series. The problem is, and you'll see this especially when we get into section 10.7, not all of these functions are easily integrable, all right? Not all of them are easily integrable. And some of them, a lot of them, will not be integrable with the methods we know, all right? For more advanced things. But integral test is helpful. P-series, 1 over something to a power, if like 1 over k squared or 1 over k cubed or 1 over k to the 1/2. If that power is greater than 1, it converges. If it is less than or equal to 1, it diverges. We're not going to do these yet. Those are coming in a future section. Today, we're going to get these two. They're on the back of that sheet. So before we do that, let's just review a few things. We know that this series does what? Converges or diverges?
Converges.
Does not converge. What do we call this series? There's a name for it.
The harmonic?
The harmonic series. And if you apply the P-series test, 1 over K, what is P? 1. So P is less than or equal to 1 up there, diverges. This one diverges. It is called the harmonic series. And I'm reviewing this because it's important. And remember, this is the one where when we did the integral to infinity, we got the thing that had an infinite amount of area under it. But when we rotated it, we got a finite volume and an infinite surface area. If it was a can of paint, it would hold a finite amount of paint, but it would not hold enough paint to paint itself. Crazy, huh? So this goes back to that. This is a pivotal series. We will be thinking about this often. Something else I want to make sure we're aware of. Natural log of k is less than k for, I think it's k is greater than or equal to 3. Remember, natural log is basically log with a base of e. So we're saying, e to some power equals this number. So if this number is e, then e to the 1 equals e, right? What is the decimal approximation for e? 2.718. So if this is 3, 2.718 to some power has to equal 3. So 2.718 to the, like, 1 point something power would equal 3, right? Because E is 2.718, that's why K has to be greater than or equal to 3 for this to be true. But just know that this natural log of a number for any number greater than or equal to 3 is less than that number. What happens to a fraction as the denominator gets bigger?
You get closer to 0?
Yes. So a fraction, as the denominator increases, the numerator remains fixed. The value of the fraction gets less and less and less, doesn't it? So this decreases as K increases. And you're correct, it approaches 0 as K increases infinitely. So these are some key ideas that we're gonna need to have in the back of our mind as we apply these two tests that we're gonna get today. So we're in section 10.5 now. The title is Comparison Test. Comparison test. The two tests that it's based on, which are this one here, comparison test and limit comparison